Alrighty then, all you cool cats and kittens out there. I hope you are ready to see the end behavior puzzle piece activity answers. So I know a lot of us were having difficulty with end behavior. And I hate saying things are easy. I absolutely do. But of anything in this unit, end behavior is the easiest because you have that chart that tells you when it's up, up, when it's down, down, when it's down, up, or when it's up, down, whatever the other fourth one is, okay? It tells you exactly what it is. So the hard part here is knowing what a degree is and knowing what a leading coefficient is. And once you know those things, you should be able to do end behavior. Okay, so let's start with the first one. I'm not going to be typing in the stuff over here because I'm lazy, but I'll probably post the answer key next week, but I just want to go through it real quick. So I'm looking at A, and this is, first of all, asking me to separate them between odd degrees and even degrees. So the first thing that I'm going to do is ask myself, well, how do I determine the difference between an odd and even degree? Well, if we go back to the notes from the end behavior investigation, odd degrees are the opposite directions. Even degrees always go the same directions, and that's the easiest way to put it. Odds also look like squigglies, where even degrees tend to look more like parabolas, but that is not always the case because you can have parabola-looking things in an odd degree, but I know that's what a lot of you said in your investigation. But again, even, they go the same direction, odd, they go the different directions. So some of you might be like, okay, but what does that mean, same direction or different direction? Well, if I'm looking at A here, on the left side of the y-axis, if I do this, it's going up. So like it's pointed up. So I just always imagine like, well, where are the arrows pointing? This one doesn't have arrows. Some of these have arrows, like H over here does. I don't know why some do and some don't, but I just imagine arrows on it. And this one arrow would be pointing up. On this side, the arrow would be pointing down. Up, down, opposite directions. Also, without doing all of that, thought behind it, you should be able to tell like if they're going the same direction or not. Let's look at B. Opposite directions. How do I know? Because they're pointing different ways. Okay. C, the same direction. They are both pointed up. The end behavior is both pointed up. So I'm going to go C. And then D, it's a parabola. They're both pointed the same direction. It's up. E, again, both pointed the same direction, up. F, see? Squiggly looking thing. Different directions. G, look at that, both down. So that means it's even because they're going the same direction. Same direction, even, different direction, odd. Look at that. This one does have arrows, and one is pointed up and the other is pointed down. Different directions. I, one is pointed down, one is pointed up, odd. Let's look at J, and K, and L. So this one, they're both going up on the left and the right. This one, they're both going down on the left and the right. So even though these two are flipped, because they're headed the same direction, these are both even. They're both even. This one is headed down on the on the left of the y-axis, and it's headed up on the right. So I want to put that with the odd because they're going in opposite directions. And lastly, M and N. M, they're both pointed downward, so that is even because they're going the same direction. N, they are pointed in two different directions. Up on the left, down on the right. All right, let's move on to activity 2. So activity 2 is very similar, but now it's talking about positive leading coefficient and negative leading coefficient. So we can't really use the directions, like if they're going the same directions or different directions, to determine this. But we can still use direction, and it's specifically the direction of the right-hand side. So what's happening on the right-hand side of the function? If it's going down, it's going to be negative. If it's going up, it's going to be positive. I'll repeat that. We're going to look at the right side of the graph. If it is going down, we are going to put that with negative. But if it goes up toward positive infinity on the y-axis, we're going to put that in the positive. This one is headed down on the right, so it's negative. And again, for these, we only care about what's happening on the right. This one is up on the right, so we put it positive. This one is up on the right, so we put it positive. This one is up on the right, so we put it positive. I'm not doing a very good job of placing these in there. That's okay. And this is up on the right, so that's positive. You see how this one is now going down on the right? It is down, so that is negative. This one is down on both sides. So if it's down on both sides, then it definitely is down on the right. So since it's down on the right, it's negative. Down on the right again, negative. This one is going up on the right. So since it's going up on the right, it is positive. Another up on the right. They're both up, actually, up on the left and on the right. So since they're up on both sides, but specifically the right, we know that it's positive. Down on both sides means that it's down on the right, so that is negative. All right, and then we have these last three, L, M, and N. Well, L is clearly pointing up on the right, so we're going to put that with positive. And then by, elimination, we know that both of these have to go down here. But let's just double check, make sure we didn't do anything wrong. These are going down on both the left and the right. So if it's going down on the right, it is negative. And then if I'm looking at N, it is most certainly going down on the right. So I'm pretty confident in our answers here. All right, so that is how you determine if something is a positive leading coefficient or a negative leading coefficient. And remember, a leading coefficient is the number in front of the variable with the highest exponent, with the highest degree. All right, so now we're going to look at them all in conjunction. So we're not just separating from even and odd, and we're not just separating from positive and negative. All right, we have to put them in all four boxes. What I am going to do first, though, because for me, visually, it's easier to determine if something is even or odd because they're either going the same direction, even, or opposite directions, odd. I'm going to put some on the left and some on the right. So here I have even on the left and here I have odd on the right. So I'm going to just move them that way. So L is even because they're headed the same direction. So I'm moving that one over here. K is odd. They can stay over there. J is going to come over here. I, you see how they're headed the same direction, is going to come over here. H, different direction, is going to move over there. G is going to come over here. They're same direction. F, two different directions, going to go over there. E, same direction, going to come over here. D, different direction. C, same direction. B, different direction. And A, different direction. So let's start with L now. So now I have them, now I have them separated between even and odd. So I have my evens on the left and my odds on the right. But now, even though I know these are all even over here, I have to separate it between positive leading coefficient and negative leading coefficient. And if you remember back to the last activity, the way that I do that is by looking at the right side of the graph. If the right side of the graph is headed downward, then it is negative. If it is headed upward, then it is positive. So if we're looking at L, L is headed downward. So we're going to put that right up in there because it is negative. J, left and right sides are down. So that means this is negative because it is going down on the right. I, both of these are headed up. So that means it's up on the right and therefore positive. G, both of these are down. So that means the right side is down and that it is negative. And then again, basically by process of elimination, we know both of these are going to go in here. But just double check. Up on the right, yep. Up on the right, yep. Cool. So I'm confident in these 6 answers. Now let's look over here with the odd ones. So I know all of these are odd. So now I just need to determine, are they positive or negative? Again, positives are going to go up on the right. So B is headed up on the right. So I know that's positive. A is headed down on the right. So I know that's negative. D is headed up on the right, so that's positive. F, you see it's pointing downward on the right. And I want to talk about the right and left real quick. You see how this one, the whole function, the whole graph is to the right, quote unquote right, of the y-axis. So I just want to make sure that when we're saying right and left, we're talking about the ends, specifically the ends. So this up here would be the left end, and this over here would be the right end, because on the graph itself, the line, the graph itself, has a right side and a left side. So that's what we're talking about, not specifically the y-axis being left and right, but the graph itself. So over here is the left of the graph, and here is the right of the graph. And since the right of the graph is headed down, then it's negative. All right, and these last two linear graphs, one is headed down on the right, H, so that is going to go with negative, and K is headed up on the right, so that is going to go with positive. All right, and that is how you determine specifically if something is even, odd, positive, or negative. Those are the 4 different types, specifically from graphs. So I'm going to end the video here, and we're going to move on to activity 4 in the next video.